Hey there! Imagine a place on Earth that's just like Venus. It's Chile's Atacama Desert. I assume you wouldn't want to spend your holidays there. Similar to other deserts, this one isn't exactly the friendliest place. It's a long stretch of land close to the Andes Mountains. This makes it one of the driest spots on the planet. In fact, it's so dry that only a few places in Antarctica have stayed without rain for longer. This tough environment has some benefits to offer. Because it's located high up and doesn't have many clouds or a lot of light pollution, it's become the perfect home for advanced telescopes. These telescopes help us explore the cosmos. A new study from June 2023 revealed that this desert is even weirder and more out of this world than we had thought. It makes sense that a desert as dry as this one gets a lot of sun. On average, it has about 308 watts of sunlight per 10 square feet. That's almost twice as much as places like Europe or the eastern United States get. Raul Cordero is a scientist. He and his team checked out the sunlight in the spot housing the biggest telescope project ever, the Atacama Large Millimeter Array. And this is the sunniest place on Earth. This is what you'd experience if you were about 79% of the way from the sun to Earth. Of course, if you were actually on Venus, you would have way bigger things to worry about than just a lot of sunlight. Now let's figure out why this place is almost as sunny as Venus. It's because of clouds. Usually, clouds block sunlight and keep us cool, but sometimes they can act like a magnifying glass in special situations, concentrating the sun's rays. This is called forward scattering. This happens when certain types of clouds show up during the South American monsoon in the middle of the summer. During the summer in the southern hemisphere, we're actually a bit closer to the sun, and there's less ozone in that part of the world. This combo might explain why other high places on Earth, like the Himalayas, don't get as much intense sunlight as this desert. Let's talk more about Venus. What would it be like to stand on the surface of this planet? The more you learn about this sweltering world, the less you want to picture yourself there. It's not a friendly place at all, with crazy heat and super heavy air that could crush you. But pretend for a moment that you're on Venus. The air there is thick and heavy, 93 times denser than what we have on Earth. The air presses you down. Think of having a small car resting on your thumbnail. That's how it would feel. Or think about diving really deep into the ocean. You'd feel a lot of pressure pushing on your body. But on Venus, it's like having all the pressure of the atmosphere squishing and almost flattening you. What is the weather like on Venus? Ouch! Heat. Even though Mercury is closer to the sun, Venus wins the prize for the hottest planet's surface. That thick air on Venus is mostly carbon dioxide, which acts like a blanket. When the sun shines on Venus, the heat gets trapped by this blanket of air, and the planet heats a lot. Temperatures on Venus can hit 860 degrees Fahrenheit. Now, how do we explore Venus without getting roasted or squished? Well, going there in person is a no-go. Robots can handle it, yet even robots have struggled on Venus. Only a handful have made it to the surface. And they only managed to survive for a few hours before getting wrecked by the harsh conditions. The good news is we're figuring out ways to study Venus without putting anyone at risk. Future missions will check Venus out from above. Spacecraft up there will be able to see through the atmosphere without any trouble. NASA's got the Veritas mission. Its aim is to make detailed maps of Venus from orbit, giving us a new view of the place. So we've examined the driest desert on our planet, the Atacama Desert. No wonder this area is the place that serves as testing grounds for space missions. But despite how arid this region is, there is life there. This is a realm of flamingos and lagoons. The place has colossal salt flats that extend for 4,633 square miles at a depth of 82 feet. It's a place of erupting geysers, naturally heated springs, towering volcanoes, herds of llamas, and deserts so parched that certain pockets have remained untouched by rain for over half a millennium. All this unfolds 2 to 3 miles above the sea level. What else survives in the Atacama Desert? It's quite hard to fathom that plants could thrive in such inhospitable conditions. Yet, they manage to survive here. Take, for instance, Tillandsia landbecki. These plants defy the odds in the desert by extracting moisture from the fog that rolls in from the nearby coast. This fog water can also serve as a sustainable water source for humans. These plants lack traditional roots. Instead, they use their older, deceased parts to anchor themselves in the sand, forming little dune-like structures. They draw moisture out of the mist through their slender leaves and shoots, which swell upon contact with water. Nocturnal dew also provides water, particularly during the summer when fog is scarce. Together, plant communities existing there are known as lomas vegetation. The presence of this vegetation in the Atacama Desert is limited to a narrow coastal area where fog regularly occurs. Factors such as the distance from the Pacific, prevailing wind direction, and topography restrict the distribution of fog ecosystems. Satellite data analysis reveals that plants grow at altitudes ranging from 2,625 feet to 4,100 feet above sea level and up to 28 miles inland. They are mainly found on sandy plains along fog corridors or on slopes. They're about as tall as 1.5 feet, and they usually form a line. This clever lineup helps them catch all the moisture and yummy nutrients they need. The arrangement of these clusters depends on how much foggy water they can find. These tough desert plants are like water wizards of the plant world. They're so good at surviving in the desert that they give us ideas about getting water from fog. Water is precious in places like Iquique and small villages near the desert. Plus, with all the digging for stuff like copper and lithium, which makes batteries work, they need even more water. Usually, people get drinking water from under the ground, but these little plants have something to teach us. Using this trick, we're making a map showing where these plants like to party most. This map could help us find perfect spots for catching fog with special nets. Here's another idea that will make you feel like you're on the surface of another planet. Pelican Point is in Namibia. You might not expect it, but Pelican Point is actually a great place to surf. Every year, it only gets around 0.30 inches of rain, but that doesn't stop surfers from riding the waves. The weather is kind of unique here. It's hardly ever too hot or too cold. This place has an unusual type of dry climate, thanks to the cold ocean currents near the bay. Skeleton Bay, alternatively named Donkey Bay, is an iconic surfing location. The surf wave crashes onto the sands of Pelican Point, situated about 5 miles northwest of Walvis Bay, a compact harbor town famous for its sand dunes and secure anchorage. Would you surf there?
When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic, smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60 but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts.
Suppose everyone in the world wants to do this, and countries started investing billions of dollars in this project. In that case, we can colonize the ocean floor. The question is, why would we need this? For the same reason we're going to colonize Mars, to save Earth from overpopulation. Why do we need to move to the red planet in the near future if we can live underwater? It'll be cheaper, safer, and most importantly, not far from our home. You don't need to stay in cryocapsules for years to wake up hundreds of millions of miles away from your planet. It's much easier to take an elevator down to the underwater city, hang out there, and enjoy the views of marine nature. Besides, staying on Mars will surely cause severe mental problems for people. Panic, stress, and the realization that you can't return to your home whenever you want can put serious pressure on your mind. It's better to live under millions of tons of salt water, and the reason why we have to do this is a need for more resources. There are about 8 billion people on Earth right now. Some experts think that when the number reaches 10 billion, the world will begin to run out of food, fresh water, and fuel. Agriculture and other industries simply won't be able to develop so quickly. Resources will be depleted, and people will have to do something to survive. The colonization of the ocean is an ideal solution to the problem. Firstly, we have very little information about the ocean. We've studied space much better than the ocean on our planet. Most likely, vast reserves of fuel are hidden under the seabed. Secondly, we will be able to reduce the load on our planet by about 50% if we move to live in the ocean. Thirdly, there will be no problems with logistics. Delivering food, necessary equipment, and construction materials will take hours, and if something breaks along the way, you can return to the surface and try to deliver it again. Sending things to Mars would be much more complex and expensive. Imagine that halfway there, millions of miles away from Earth, something breaks down on the spaceship with provisions. Then you'll have to wait for many years for the next delivery. But the main reason for ocean colonization is protection from disasters and natural cataclysms. Volcanic eruptions, radioactive winter, earthquakes, tornadoes, and floods. We could easily wait out any disaster underwater. Yeah, there are volcanoes on the ocean floor too, but the consequences of their eruptions are not so dramatic. The water immediately cools the lava and prevents ash from spreading. We will never experience the consequences of fire again. No burning forests and polluted air. And speaking about the air, there's a lot of oxygen in the ocean. More than half of the oxygen reserves on the planet are replenished by the sea, thanks to algae and phytoplankton. So don't worry, we'll be able to breathe deeply. The main thing is to figure out how to do it underwater. When humanity decides to take such a global step and begins to colonize the ocean, we will first have to adapt our bodies to high pressures. There's such a thing called saturation diving. Before descending into the depths, you must inhale compressed air. The nitrogen and oxygen quickly dissolve in your blood and exert pressure on your body from the inside. At the same time, the water pushes on it from the outside. In simple terms, your body is in balance and you don't feel bad. Divers use this method when exploring the seabed at great depths. Therefore, when people begin to colonize the ocean, they will dive there wearing cylinders with compressed air and an oxygen mask. The main rule is to surface slowly. You need to wait until the compressed air completely dissipates inside your body. If this isn't done and you rise to the surface, then you will feel intense pressure from the inside. Nitrogen will start acting in your veins like soda bubbles when you shake a can with the drink. After this adaptation, we will start building cities, roads, and stations that will transfer people to dry land and back. It shouldn't be too difficult because we already have the technologies needed for the underwater lifestyle. Welcome to the Aquarius Reef Base, located at the bottom of the Florida Keys Marine Reserve. This is a small laboratory where 6 people can live for 10 days. Scientists working there study coral reefs, marine plants, and fish. The lab doesn't look modern. It resembles a sunken, rusty bathyscaphe overgrown with shells and other underwater stuff. To create buildings with more beautiful designs, people will need new technologies for underwater construction. So let's imagine that global colonization has begun. Engineers use durable stainless metals and other materials capable of withstanding high pressure. With the help of freight elevators, people lower everything needed for large-scale construction to the bottom. Stations with such elevators appear in all the seas and oceans. Workers build huge underwater constructions on dry land. Then, large ships deliver them to the stations. From there, they descend to the bottom, where scuba divers and robots set these houses on the ocean floor. Every building is like a giant submarine with lots of apartments. They look ordinary from the inside, except for the underwater view from the window. To reduce waste emissions, engineers build huge capsules in every city, where garbage is destroyed by high water pressure. People try to live closer to the shore because they want to spend less time commuting. This causes severe pollution in coastal areas. Builders set up communication between the stations and land by creating vacuum tunnels with high-speed trains inside. In simple words, this is an underwater subway, only much faster than the one on dry land. From now on, people move farther from the shore to live in cleaner water. Humanity begins to make daily life in underwater cities more comfortable when the main construction is over. Scientists create filters that can quickly purify seawater. Now, everyone has a faucet that takes water directly from the ocean and turns it into fresh water. Also, constructors put in air filters capable of extracting oxygen from the water. Electricians create underwater mills to generate energy. To leave home, a person must put on a diving suit and cylinders with compressed air and exit through an airlock. People swim between buildings and talk to one another using radio communication. For faster movement, car companies produce small bathyscaphes with locked cabins and powerful propeller systems. Over time, engineers create large domes where you can walk and breathe fresh air, like on land. Global clothing brands develop fashionable diving suits and practical accessories for comfortable underwater movement. For example, you can attach a small heater to your clothes to not freeze while swimming. And you can also put on wider fins with engraved brand symbols. To make such a lifestyle as comfortable as possible, scientists and biologists create masks that work like gills and provide a person with oxygen extracted from the water. Constant exposure to high pressure changes people's physiology over time. In the water, we need to put more effort into moving. People who often leave their homes lose a lot of calories. They become slimmer and their muscles get stronger. Look at the Olympic swimming champions. Now, almost all underwater citizens have the same developed shape. Our body temperature is falling, and evolution slowly turns us into cold-blooded creatures. A lack of sunlight makes our skin paler, and we start resembling amphibians. We learn more about deep-sea creatures such as the giant squid and other monsters. Almost every month, scientists discover new species. But at the same time, many fish species disappear because of human activity in the ocean. The extraction of natural resources from under the seabed heavily pollutes the water. To reduce the load on the planet, people decide to colonize the sky. But this is a topic for another video.
Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So, if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years. Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangea also had a massive water neighbor called Panthalassa, so our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things changed. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So, if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
You are lost deep within the jungle in the Yucatan Peninsula in Mexico. There are strange noises all around you, and to make it worse, the sun is setting. Soon, you'll be alone in the middle of an unknown rainforest. Guess it was a pretty bad idea to come looking for El Dorado on your own, wasn't it? You keep walking as fast as you can, when suddenly, wait! What's this you're seeing? It looks like large stairways made out of stone. This definitely doesn't look natural, so you take a picture. Maybe you didn't strike gold, but you might have just found something relevant. Congratulations! You found Ocumtun, a long-lost Mayan city, hidden 37 miles into the jungle. The name literally translates to stone column. Stone was probably in at the time, so these guys used a lot of it to build their pyramids, houses, and even ball courts. If you ever thought that Europeans invented ball games, think twice. Mayans love to play ball games for recreational purposes. Ancomtun is part of a series of other long-lost Mayan cities that are being discovered with the help of new technology nowadays. We'll talk more about the other ones in a jiffy. Perhaps the biggest surprise of this one is that it was surrounded by wetlands, which is why the city was built on high ground. The city was monumental, covering an area of over 120 acres. That would be as big as 90 football fields right next to each other. Scientists have found proof that Ancomtun had pyramids of up to 49 feet high, and that it was likely an important social hub between 250 and 1000 CE. This is definitely a game changer. But lost Mayan cities began to be unearthed in the 19th century. Modern technologies, such as Lidar imaging, help archaeologists see through dense canopies of the forests. This means that people don't really have to risk getting lost in the tropical jungle like you did at the beginning of this video. Lidar works sort of like an X-ray. It sends out laser beams that can detect any signs of ruins or ancient constructions. According to space archaeologist Sarah Parchak, satellite imagery has been a key player in discovering ancient cities in South America, Egypt, and other places. Sarah herself spends most of her days scouring images for any signs of where there could have been cities long ago. She says that more often than not, what happens is that ruins are covered by vegetation, soil, or sand, which makes them super tricky to find. But thanks to these awesome tools, scientists also made the huge discovery of ancient Mayan causeways, which spread throughout old Mayan territories. I mean, take a look at these roadways. You'd expect to see ruins like this in places such as Portugal, England, or the United States. I'm talking about 130 feet wide roads painted white to help travelers journey through the nighttime. Scientists recently unearthed a 110-mile network of roads such as these, and they think this dates back to before the first registered Mayan highways we've known so far. These roadways, which sometimes ran over the swampy ground and were even elevated at times, are being called the world's first superhighways. Even if there is no registry of animal-powered vehicles, it's believed that the Maya used them to travel around a network of possible 964 settlements. They were built like a huge spiderweb, and from what archaeologists have gathered, this huge system of roads worked to connect a big system of economic and social interactions between Mayan cities. This completely debunks the traditional idea that the Mayan pre-classic period, which dates back to 2000 BCE, was made of small, tribal settlements. Imagine the manpower and engineering ability you need to muster to build something close to these white highways. Scientists believe that these causeways were built pretty much the same way as the Mayans built their pyramids, with a mixture of mud and quarry stone. Oh, and using several layers of limestone to make them white. That's pretty cool, right? But let's take a few steps back for a moment to get some context. The Mayans were one of the biggest pre-Columbian civilizations living in the Americas. Until now, experts believe that at its apex, the Mayan civilization consisted of over 40 cities, with a population of millions of people. That's a lot of folks. Their civilization spanned Mexico's Yucatan Peninsula, Guatemala, and Belize. And they survived mainly on agriculture. The thing is, the Yucatan Peninsula was an extremely difficult place to grow crops. So the Mayans had to develop a complex irrigation system in most of their cities. They built a series of ceremonial buildings, pyramids, and plazas. The Mayans might have been keen pyramid builders, but they also developed an advanced astronomical system. With whatever ancient technology they had, they were able to predict the exact location of planets such as Venus and Mars, as well as the exact dates of eclipses. If you've ever seen examples of ancient Mayan cities, this is Tikal. Located at the heart of the Guatemalan jungle, Tikal is believed to have been the capital of the ancient Mayan conquest state. At its height, it was comparable in importance to cities such as London or New York in today's world. It's composed of a series of complex monuments. The North Acropolis is one of Tikal's most ancient complexes of monuments, built solely by human hands around 350 BCE, It served as the resting place of kings and chiefs. Its monuments are up to 200 feet high. Back in the day, the step pyramid temples were painted a beautiful red. Mayans loved that color. Today, of course, you'll only see the limestone. Then there's Chichen Itza. It's got one of the best preserved pyramids on Earth to date. Located in Mexico's Yucatan state, this Mayan city is well over 1,500 years old. At its peak, it was home to 35,000 people. The site covers 4 square miles of land. The highlight is El Castillo, a tremendous step-like temple standing 80 feet above ground. Its most peculiar feature is that it has 91 steps up each of its 4 sides, including the upper platform, which makes for 365 steps, the same number of days as the solar year. You can see that these folks were a pretty big deal, huh? That's why nobody can really understand what happened to them. There's a big lack of evidence on the decline of this almighty empire. What could have been the cause of their demise? Was it a drought? New research in 2017 did bring some new discoveries into the mix. Using data from a site at Ceibal, located at southwest of Tikal, scientists analyzed radiocarbon data from ceramics and archaeological excavations to extract new information about the unexpected demise of this great civilization. The information shows that instead of a sudden collapse, the Mayans most likely fell in waves of social instability and political crises. These events are believed to have deteriorated Mayan city centers and began causing the dispersion of the Mayan population. It's hard to pinpoint the exact causes, though. But hey, recent discoveries are shedding a big light on humanity's past. Not only about the Mayan Empire, but about other long-lost civilizations of South America. A major recent discovery in Brazil was done using satellite imaging technology and is also shocking scientists. Some images from near the Xingu River, also in the Amazon, suggest that cities of millions of people might have existed inside the jungle, way before our modern civilization ever existed. I mean, if this doesn't shock you, I don't know what will. Satellite imagery also detected a network of trenches dating back to 200 and 1,200 CE in the Bolivian Amazon forest. These proofs suggest settlements that could have supported around 60,000 people right in the middle of the Amazon forest. When researchers from the University of Florida went on ground to check the satellite information, they were shocked to find several mounds that were accompanied by ditches and geoglyphs. Archaeologists also found remnants of carefully designed walls centered around plazas, much like the type of construction done by the ancient Mayans. Solar eclipses are amazing to witness because the moon and the sun seem to overlap perfectly in our sky, even though the sun is way bigger, about 400 times. The trick is, the moon is also about 400 times closer to our planet, so they end up looking the same size to us. Sadly, at some point during our planet's history, solar eclipses won't happen anymore. You see, the moon is actually drifting away from Earth, sliding away about 1.5 inches every year. Because of this movement, the moon will no longer completely block out the sun. Experts at NASA went on to calculate when the last solar eclipse will happen. They say it's still going to take about 600 million years, so it's safe to say none of us will be here to see it. Speaking of things we won't see in our lifetime, we might need to add stars blowing up to that list. We know what stars look like when they fade away because of telescopes, but we've never seen one with the naked eye popping up above us. Betelgeuse might not sound like a familiar name, but know that it's a red supergiant star located about 1,000 light-years from us. What's special about it is that it might explode and put on a spectacle that's never been seen from down here on Earth. This star has always been a bit of a mystery in terms of when it's gonna pop. What we do know is that Betelgeuse is in the late stages of core carbon burning. And this carbon burning phase typically lasts around 1,000 years. Chances are we won't be seeing any stars collapsing anytime soon. But since this event will most likely be harmless for our planet, it's something exciting for future generations to look forward to. Also, if you're curious to spot Betelgeuse in the night sky, it's usually visible in January and February evenings, and by early August, you can catch it before sunrise. It's got this unique muted orange-red hue, perfect for showing skeptics that stars do indeed come in colors. Our planet will also suffer a lot of changes in the future. If we could travel some millions of years ahead, we might not recognize our planet's maps at all. Currently, Earth has 7 continents, but it hasn't always been that way, and it will most likely change in the future too. About 310 million years ago, Earth had this megacontinent called Pangea. Around 180 million years ago, it started to break apart. Now, scientists think that in the next 200 or so million years, we might see another large continent forming. In fact, we might be right in the middle of this whole supercontinent formation. There are 4 main scenarios of how this new land could come to be, each with its own twist. They all link back to how Pangea split up and how our continents are still shuffling. Our day, the 24-hour cycle we live by, is slowly stretching out too. This sneaky, gradual change will eventually lead to days that are 25 hours long. And here's why it's happening. Earth's rotation, that spinning we do each day, is getting a bit slower each year, and it's all thanks to the moon. That's because our satellite is sort of stealing some of Earth's energy. We know this is happening because of a cool gadget called the Laser Ranging Retroreflector. It shoots laser beams up at the moon, and when those beams bounce back to Earth, it takes a tiny bit longer for them to return. This little delay is a clue that our days are stretching. So, how much longer until we get 1 extra hour each day to finish up our to-do lists? Well, experts over at NASA did some calculations. Over the last century, our days got about 1.4 milliseconds longer. And if we zoom out and look past the 2,000 years, using historical records of solar eclipses, our day has stretched by an average of 2.5 milliseconds every century. Tedious calculations aside, we'll need about 50,000 years for a single extra second to be added to our day. That means it will take 180 million years for a day here on Earth to have 25 hours. That is, of course, if nothing else happens to our planet's rotation in the meantime. The Milky Way and one of its closest neighbors, Andromeda, are planning to merge somewhere in the future too. We won't be here to experience this interaction, but it probably won't feel like much of a change from down here on Earth. Galaxies colliding may seem a bit unusual, especially since we know the universe is expanding. If galaxies are moving further and further apart, how come they still get to meet with each other? Well, galaxies that are close don't just float around. They each have an effect on the other, thanks to gravity. That's the reason why the Milky Way and Andromeda are moving closer at about 186 miles per second. If we do the math, it means their collision won't happen for another 4.5 billion years, and chances are they're going to gently pass through each other, without visible changes being felt from within our solar system. There will come a time in the distant future when Saturn's stunning icy rings won't be here anymore either, at least according to some new research. NASA's Cassini mission, which spent its time orbiting Saturn between 2004 and 2017, gathered some new information about these rings and when they might disappear. You see, scientists have been debating for a while how old Saturn's rings are. Some thought they must be pretty young because they're still so bright and icy. They figured that over billions of years, they should have been worn down and darkened by all the space objects crashing into them. In fact, it's possible that these rings were still taking shape when the dinosaurs were roaming the Earth. When foreign space objects sneak into the rings, they shove material from the innermost circle towards Saturn at a pretty fast pace. As a result, Cassini saw the rings losing tons of mass every second. That means these rings aren't going to be visible for too much longer, in cosmic terms at least. They're estimated to last maybe a few 100 million years at most. We might also miss this next cosmic event, but barely. That's because according to some estimations, it might happen in just 100 years. The Earth's magnetic field might collapse, flipping its north and south poles. Researchers claim that for the past 3,000 years, our planet's magnetic field has been on a steady decline. And if this trend continues, we might hit a critical point in less than 1,000 years. For the planet's poles to switch, the magnetic field needs to weaken by about 90%, and this can take thousands of years. During this vulnerable phase, our planet loses its protective magnetic shield, letting in more cosmic rays from space. The last time this pole flip happened was almost 800,000 years ago. Problem is, we're currently in one of those riskiest phases. The field's getting weaker, but there's a chance it might regain its strength. At this rate of its decline, though, it could nosedive to nearly zero in just a few centuries or a millennium. And we're already witnessing the effects of our weakening magnetic field on our satellites. In the vast expanse of the Atlantic Ocean between South America and Africa, there's a region where Earth's magnetic field is 3 times weaker than at the poles. Scientists call it the South Atlantic Anomaly. Satellites passing through this zone consistently face electronic problems. No one knows why this weak field region appeared in the first place, and predicting its future moves has been pretty inconclusive. One theory is that a massive swirling whirlpool in Earth's liquid metal outer core might be responsible, pushing the magnetic field away from the South Atlantic. Another thought is that the magnetic field in this region is pointing in the wrong direction, like a mini pole flip.
It may seem that today, with our quite advanced technological development, science can explain pretty much any natural phenomenon. But that's not always true. Some things still stump experts and make them build exotic theories. Let's have a look at some of such phenomena. Hessdalen lights are a puzzling phenomenon you can observe in Hessdalen Valley in central Norway. The thing is that some highly unusual lights can often be seen over the valley. They appear mostly at night. The lights are typically white, but they occasionally turn yellowish or reddish. Nobody knows what makes them change color. What's more, the lights can move. And if at one moment they seem to motionlessly hang in midair, the next minute they may travel somewhere at lightning speed. There's no certain place where they appear, and you can't predict the duration of their stay. Despite all the research that has been done since the 1980s, scientists are still unable to explain this phenomenon as well as such weird behavior of lights. The sardine run lasts from May to July. During this time, millions of sardines swim northward along South Africa's east coast. You can probably imagine a feeding frenzy that starts at that time. It's believed that the water temperature must get lower than 70 degrees Fahrenheit for the migration to begin. This mushroom with a difficult name, Corioactis gister, is only found in Japan and Texas, and it makes scientists extremely confused. Why these two locations? It's true that they're on the same latitude, but these places are definitely not the only ones. Plus, they're so far away from each other. After studying the mushroom's DNA in 2004, experts suggested that the two populations might have been separated into two lineages around 19 million years ago. On Central Flores Island, there's a 3,000-foot-high volcano called Kelimutu. At its base, there is a small town. If you want to see the main attraction of the area, you'll most definitely stay there. And the attraction I'm talking about is 3 lakes, known as the Lake of Old People, the Lake of Young Men and Maidens, and the Enchanted Lake. Why are these lakes so popular and attract so many people? They inexplicably change colors. Ancient legends claim that the lakes are the final resting place of human souls, and those souls stay in different lakes according to their actions. As for scientific research, No one has yet conducted any to discover the cause of the changing colors. But theorists suppose that it might be due to underwater volcanic activity. It might be pushing minerals to the lake's surface. Then, depending on what elements those are, the lakes can turn blood red, bright turquoise, or olive green. But the coolest thing? The lakes are never all the same color at the same time. This phenomenon is unique and hasn't been observed anywhere else in the world. Those who have ever heard an annoying noise a kettle makes to inform you the water inside is boiling can imagine what the whistle sounds like. Even though this noise isn't as blood-curdling as some other unexplained sounds, it doesn't make the whistle any less mysterious. It's incredibly elusive. In 1997, only one underwater microphone was able to pick it up. At that time, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the unusual sound is an eruption of one of the submarine volcanoes. But once again, there's not enough proof to make sure. There's probably no person on Earth who doesn't marvel at the mystery of the Bermuda Triangle. But not everyone knows that there is another triangle. Not so famous, but just as dangerous. Dragon's Triangle, or the Devil's Sea, lies in the area between Japan and the islands of Bonin. It covers a big part of the Philippine Sea as well. That's why people also call this place the Pacific Bermuda Triangle. Surprisingly, or not really, the Devil's Sea is situated exactly opposite the Bermuda Triangle. Ships and planes tend to disappear here with the same regularity as in the North Atlantic Triangle. People also report seeing ghost ships in the open sea. And while scientists provide logical reasons for the vanishing vessels and aircraft, most people still believe in the paranormal nature of Dragon's Triangle. For the first time, a bizarre sound, later called the upsweep, was registered in 1991 in the Pacific Ocean. One of the most unusual things about the sound is that it's constantly changing. It varies from high to low frequencies and then back again. You can hear it better in the spring and fall than in the winter and summer. The sound travels from the bottom of the ocean toward its surface. Scientists do have a theory explaining this phenomenon. They think it might be the activity of undersea volcanoes that causes the sound. Hot lava that's pouring into the ice-cold ocean water can theoretically produce such noise. But researchers haven't found any evidence to confirm this theory yet. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Potomsky Crater is described as a mount with a perfect shape. Its size is more than that of a 25-story building. It sits in the middle of the woods with its top chopped off and presents quite a sight. In fact, the shape of the crater is pretty unusual. It has a rounded inner dome that is about 40 feet high. At first sight, this formation looks like a volcano, but after a closer examination, you might realize that it's not the case. The dome in the center of the cone is extremely unusual for a volcano. In addition, there haven't been any volcanoes in this region for millions of years. while the age of the crater is estimated to be about 250 years. The weird shape that the crater has is like nothing scientists have ever seen. This, as well as the fact that any theory fails to explain the origin of the formation, adds to the mystery around it. And that's not the most terrifying thing. After researchers analyzed the growth rings of the trees near the crater, they found out that the trees experienced a period of strangely accelerated growth that lasted for 40 years. After that, they began to grow as they were supposed to. The level of radiation near the crater is also higher than in the nearby areas. No one has an explanation for this fact. On top of that, nothing grows on the blood-chilling formation. Perhaps because the crater also has a lovely habit of constant shifting. It rises and falls, influenced by some inexplicable force. Locals believe in the evil that dwells in that place. While exploring the Amazon rainforest, researchers discovered gigantic geoglyphs. They're geometrical drawings carved into the ground. The trenches were as large as 36 feet wide and 13 feet deep. They were created at different times, most between the 1st to the 15th century. There are more than 450 geoglyphs in the north of Bolivia and Brazil. The most ancient of them could have been created around 3,000 years ago. The huge earthworks were likely used for common meetings and discussions, but scientists haven't found enough proof yet.
Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape, kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped. Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases! Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during this second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.